Hi, today we are looking at section 3.3, which is sketching graphs of rational functions. To graph a rational functions, we first need to determine the non-permissible values of our x, which will give us our locations of holes and any vertical asymptotes. We then also need to figure out the equations of any horizontal or oblique asymptotes, figure out our intercepts, so that's both our x-intercepts and our y-intercepts, and the behavior of our graph. So we'll jump straight into some examples. So we want to graph y equals x squared minus 5x plus 4 over 1 minus x. So I'm going to start by factoring this numerator. So I'm looking for two things to multiply to 4, add to -5. So that'd be x minus 4 times x minus 1. That's being divided by 1 minus x. Now these look similar, but the signs are exactly opposite. So what we can do is we can factor negative out of this denominator. So we'll move a negative in front and then factor negative out, changes the sign of each of these, so it becomes a positive x and then a minus 1. So those are going to cancel out, but before we cancel them out, make sure we write our non-permissible. So our non-permissible would be positive 1. And then essentially we still have to remember that x minus 4 is being affected by this negative down here. So that's going to change this to negative x plus 4. Now, because those canceled out, we know we're going to have a hole. So I'll plug in the x value, that's my non-permissible, to get my hole. So I've got negative of 1 plus 4. So that gives me y is equal to 3. So I have a hole at 1, 3. So mark that on my graph, and then I'll start graphing this function. So we have a y-intercept of 4 with a slope of -1. Plot out a few points. And then join them to do our graph. So our domain for this would be x is all real numbers, with the exception that x cannot equal 1. Our range would be y is all real numbers, with the exception that y is not 3. Next example, we've got negative 2x squared over x squared minus 25. So it doesn't look like we're going to be able to cancel anything out, but we'll still factor out our denominator. So this is a difference of squares, so it becomes x plus 5 times x minus 5. So we have x cannot equal -5 and positive 5. So that will be our vertical asymptotes. So we might as well draw those in now. And I will label them. Now looking at this, we have the same degree, so we're going to have a horizontal asymptote. At y is equal to this leading coefficient over this one, so -2 over -1, or sorry, -2 over 1, so that's just at -2. So label that one as well. And then we'll go back into finding some key points on our graph. So looking at this, we know we have an x-intercept at 0. So also happens to be our y-intercept, but that doesn't give us too much else. So to figure out where our graph goes, I would typically take a point close to this axis on the left side of it, one close to it on the right side. Same with this one here and here to get a few more points to see what's going on with our graph. So just over here would be x equals -6. So I'll try putting in x equals -6 into our equation of y equals -2x squared over x squared minus 25. So that's -2 times -6 squared over -6 squared minus 25. So that's -72 over 11. So if I plot that, that's well here. So in this first section of the graph, we're going to be looking like this. I'll then choose one over here. So for example, x equals -4. So we've got y is equal to -2x squared over x squared minus 25 equals -2 times -4 squared over -4 squared minus 25. That should give us 32 over 9. So graphing that, that should be at about here. Now, this is probably going to go like this, but we want to double check that doesn't bend down and pass down here. So we'll do an x is equal to +4. So we'll substitute in our 4. And that also gives us 32 over 9. So that will be about here. So in this center section, it's going to be coming on that asymptote, curve towards this point here, and then back up through this one. And then we'll figure out in this last section. So this would be an x value of 6. So I'll try an x value of +6. So I've got y equals -2x squared over x squared minus 25. That becomes -2 times 6 squared over 6 squared minus 25. So that is -72 over 11. So that would be down here. So this section here would look like this. So overall, our graph looks like this. So next step is stating our domain and range. So for our domain, we can say x is all real numbers, except for x cannot equal -5 and +5. Now our range, we can see that we get up close to -2, but never reach it. So we have y is less than -2. We also see that the lowest that we get in the center section is at 0. So y is less than -2 or y is equal or greater than 0. Okay, so we'll do another example. So next one, we've got 2x squared plus 5x minus 2. Okay, so we'll start out by factoring this. So first thing I would do is factor the negative out. So that gives me negative times 2x squared minus 5x plus 2 over x minus 1. Now factor the numerator over here. So in that numerator, we have 2x squared minus 5x plus 2. I have a product that is 2 times 2, so 4, with a sum of -5. Start each bracket with 2x. Two things that multiply to 4, add to -5. Would be -4 and -1. Divide, that's your factor of 2 of this one. So I have y is equal to negative of x minus 2 times 2x minus 1 over x minus 1. So we have a non-permissible x cannot equal 1. So that's going to be a vertical asymptote. So I might as well draw that in now. So at +1, I have a vertical asymptote of 1. So label that while I'm at it. And then we'll go back and find some other stuff. So this was 1 degree higher than this. So we'll do division to find our oblique asymptote, seeing nothing canceled. But before we do that, we can get our intercepts. So we have an x-intercept at 2 and another one at 1/2. So I might as well mark those out. So I've got an x-intercept at 1/2 as well as one at 2. Now, if I plug 0 into my original equation, that's going to give me my y-intercept. So if I plug 0 in, that leaves me with -2 over -1. So that gives me a y-intercept of 2. Okay, next we will do our synthetic division. So we'll do it with this original function. So we've got -2, 5, and -2. Our a value is 1. So we bring this down. So we've got -2 times 1 is -2. Add those, that gives us 3. Times 1 is 3. So we have a remainder 1. So we have y is equal to -2x plus 3, and that's our oblique asymptote. So we will plot that next. So we had a y-intercept of 3 with a slope of -2. So if we connect those points, we end up with an asymptote that looks like this. So that's our y is equal to -2x plus 3. Now, we most likely have enough points to graph the rest of this right now, because we have 2 points on this side, so we know that this is going to be coming along like this, go through these points, and then go on here. And we know it's going to essentially mirror that on the other side. So this one, Our domain is x is all real numbers with exception x cannot equal 1. And our range is going to be y is all real numbers. Okay, this is our last example, x plus 3 divided by x squared minus 9. So we'll start out by factoring our denominator. So we've got x plus 3 over x plus 3 times x minus 3. So right away, we know we have non-permissibles at -3 and +3. Now our plus 3's are going to cancel out. So that leaves us with y equals 1 over x minus 3. So right away, we know we have a vertical asymptote at x is equal to 3. So we'll draw that in. We'll also make sure we label that. And then we'll figure out where our hole is. So we'll plug in our other non-permissible value, which was -3. So we have a hole at -3 comma -1/6. So at -3, -1/6. We have our hole. Now we have a reciprocal function. So with that, we also know that parts of our graph are going to be diagonally opposite. We haven't drawn in our horizontal asymptote yet, which we should. Because this was 1 degree higher than this, we know we have a horizontal asymptote at y equals 0. So graphing this function, we know it's coming on here, goes to our hole, and then down. And this will just be diagonally opposite. Now for our domain, we have x is all real numbers, except x cannot equal -3 or +3. Our range, we have y is all real numbers, except for y cannot equal 0, or where we had that hole.